Morning, everyone. I'm really interested and happy to have this opportunity to talk with folks, many of whom in this room have developed the science basis for the carbon offsets that we are using in Alberta to, in this case, already generate about $140 million for farmers to do management improvements that reduce greenhouse gas emissions. What's really interesting in working in this area is to observe the interplay of how policy is really a large influence at a government level, from international all the way to provincial, and then the technical policy basis as well. So there's some really interesting just points I thought it would be good to raise and show how powerful policy can be. In this case, there's a lot of drivers towards reducing the science-based coefficients for reasons of conservatism and discounting and so forth. In other cases, I've seen policy double the value of coefficients. So it's very powerful, and I thought it might be interesting just to go over some of that this morning. I'd like to acknowledge my co-authors, particularly Dennis Hawk with Agriculture and Agri-Food Canada. He's in BC now, who did a lot of the technical policy that really solved some of the hard challenges to get these, the science that's measured in the field to the point where it can be used by farmers to generate income for management improvements. Karen Hogan-Kozura was a tremendous catalyst in getting the whole carbon offset system running, never mind a third of the offset protocols agricultural. But again, attributed to many of the scientists in this room who were up and running with some of the science basis that was possible, and because of federal policy, we're moving forward, and so even when the Fed stepped back, we could pick up that momentum and keep it moving forward to the point where it is now. Tom Goddard is our senior policy advisor, and he's always great to bounce ideas and get us thinking outside the box. And Len, of course, is very supportive of all our efforts and gets the instrumentation and the people that we need to get these kinds of operations going forward. And he's got a significant science component himself that he's leading, in addition to all the management enabling that he does for us. So there's a lot of hype about the potential for soil carbon. We know that in the Canadian prairies, there's a very sound basis for the idea that improving management will increase carbon levels in the soil, primarily because on the prairies we have that significant rest period that we're experiencing right now. Unlike many other areas in the world where there's continuous cycling of carbon and respiration and so on, and there's not the capacity to build carbon to the point that we can here in Alberta. And I think some people forget that when we're talking a little bit more broadly. There is the capacity. One choice that the large final emitters can make is to purchase carbon offsets. And these are very attractive to many of the large final emitters because they're cheaper than the technology contribution into a technology fund that we call the Climate Change Emissions Management Corporation, that's dedicated to technological improvements. They can purchase offsets more cheaply. And then there's also an opportunity for many of these large final emitters to be seen as green. And some of the electricity companies, for example, are interested in having that green sheen, and purchasing carbon offsets from an agricultural source has that appeal. In fact, we met with some California people from actually the Environmental Defense Fund yesterday, and they were saying that that's a really big driver for them as well in working in the agricultural area. People want to help agriculture and, associate themselves with good production practices. A little bit of the timeline that, as I mentioned, was sort of the policies kind of interwoven into this, where national greenhouse gas research was very well supported in the 90s, and significant work was done at the field scale to be able to have the body of science that's drawn upon to develop some of the models and eventually carbon offset coefficients. This is lacking in Australia and actually in California, that they've only just started some of the greenhouse gas work that, with respect to how management changes in reduce or remove, in the case of soil carbon, greenhouse gas emissions. So they're a little bit behind. They're quite envious of the body of knowledge that is available from our federal scientists. And we know that there was quite a assertive, I guess, and progressive a stance on the part of a few governments ago with respect to moving forward on agricultural carbon offsets. I think at the national level, many of the protocols that we adapted into the Alberta system were being developed at that time. And Dennis Hack was involved with the soil carbon one in particular. And I think probably a number of you folks here were also involved in some of those soil management technical working groups that related also to nitrogen management that is drawn upon as well in Alberta. And then there has still been there was draft regulations projected, quite optimistic figures as recently as 2008, but then we know what happened. We're waiting to see what the US will do, and now Alberta is in the same spot, but at least we've got some momentum and we're moving forward now. So just to talk a little bit about Alberta's offset system and how all this works, and you'll see there's a pretty big important policy piece here that draws on the science basis, because in the Alberta offset system, the offsets must be quantifiable, measurable, and have a solid foundation. But we recognize that this foundation, this rigorous science basis, has really helped us through all the vagaries of policy that have kind of come with different governments and different positions that have been taken. The policy piece that's interesting is that in the case, and it's challenging, and this is where Dennis Hack did a lot of really interesting work with his soil management technical working group, the management improvements must be above and beyond business as usual, and they must be permanent. And we know those are significant challenges with respect to soil carbon. I'll talk a bit more about that later. They must also be verifiable. And this is something that changed recently in the Alberta system. The standard of verification increased, and I think Paul might talk about that a little bit more too. So it's all about the records and proof of a practice change. So there is an international process for developing protocols. But in this case, and this is something that's interesting, because of the science basis that was developed, we don't have to actually measure soil carbon. We can measure a management improvement, a management change, a change from a baseline practice of conventional or full tillage to reduced tillage or no-till. And what's interesting about that, it's a lot easier to measure a management change than it is to measure soil carbon, as you all know. So that's quite an interesting development in the thinking about how these quantification protocols work. And it's not an obvious one. Even with these folks from California yesterday, they thought you would have to measure soil carbon. And it's such an incredibly variable and long-term process that this body of research that we can draw on has really enabled the capacity for this protocol to document some of the things that are needed to move this forward. A lot of monitoring and verification requirements are described in the protocol. It's almost a license, a prescription for what you have to measure, what tracking is important. It needs to be verifiable by a third party, for example. But it does reduce cost because it's prescribed and it's becoming more standardized. And because it's assured by government approval of the protocol, third-party verification is an important part of that, but there's also registration on an offset registry. So there's kind of a shop window. There's tons available for sale. So it provides certainty for investors. So all those policy pieces that were built are kind of enabling this instrument. It's really a market instrument, it's not a commodity at all. So again, I think we talked already about some of the work that had been done by the Federal Science and drawn into a compendium by Vanden Bijgaard and Angers, Denis, and others. And that some of this then was drawn into a validation study that was used as a basis for the Soil National Inventory Report. So out of 13 studies that were published in the prairies, the best 5 with criteria for high quality were chosen. So more than 10 years of data, equivalent mass basis calculations in there, and were published. I'll show you a graph in a few minutes to just show you what happens when you start looking through all this as it gets sieved out, what goes forward in the protocol. And then there was some modeling the century coefficients, because as we know, we can't just take the results at a field scale and extrapolate it to the province. We've got different rotations, different cropping, and so on. So a lot of the work by McConkey and others were involved in this. And that's, again, used for the National Inventory Report, but we were drawing on that for the protocol. And not just removals are accounted for in the protocol, but also reductions in N2O emissions. Philippe Rochette did a lot of work where the N2O it can be extracted just based on the tillage. It's not the same as what's in the nitrous oxide emission reduction protocol, which is more about fertilizer management. And then there's an energy use component as well. So another kind of policy decision, I guess, around carbon offsets is to look at using just a partial life cycle, where we're only looking at the management practice improvement. It's not a full life cycle. We're not going all the way upstream every time. We're recognizing in the case of carbon offsets, there's always the same amount of seed being planted, always the same amount of grain roughly being harvested, but what's changing is the tillage practice in the middle. So the partial life cycle approach is just looking at that piece. So the upshot of all this, which is quite interesting, is that these highly variable measured studies, in fact, this is the subset, the 5 out of 13 studies. When you look at the 13 studies, it's even a wider, broader range of variability, which is, I'm sure, the reason why they chose just the high quality data. By the time you work it through the models of for century, bringing in summer fallow, different crop types, it's not always wheat, sometimes canola, it's not building the soil to the same level, carbon in the soil. And then there's these other 2, baseline adjustment and a reserve discount, that I'll talk a little bit about more. But as I said, at the end of the day, the measurements that we are all used to talking about at these conferences ended up being probably about 1/3 of the value by the time all these policy approaches and including this conservative choice of how to settle on a stable coefficient to go forward with and extrapolate it beyond. So that was quite interesting. Okay. So here's just a graphic of the modeling. I guess we don't really need to get into that. The baseline and project emissions are quantified in the protocol. And then there's an assurance factor describing the probability of reversal. But first I wanted to talk a little bit about this additionality approach, because again, it's a policy decision that was actually developed by the Soil Conservation Council of Canada, AAFC, and many agricultural representatives, including producers. And it was, I think, very clever, the idea to set a baseline to 0 to indicate that only the new carbon that's being converted from full till to no-till or reduced till, only that carbon gets allocated proportionally among all the participants who want to be involved in creating carbon offsets. So it gets at that question of why is it that the laggards are getting rewarded when the early adopters are not. This was, I thought, quite an interesting policy decision to make it more equitable, so that people who were early adopters could also have the benefit of engaging in the carbon offset markets, just not the ones who are making the change most recently. And this is starting to get cited a little bit beyond as far as a way to distribute the opportunity to participate in some of these management improvement incentives. And then there's the question of permanence that comes up an awful lot with respect to soil carbon coefficients. And this sequestered carbon reserve is the approach that was actually developed in the voluntary carbon standard initially, and it's been also used in afforestation. So a lot of this policy has been borrowed, of course, from other areas and goes back and forth. But the idea then was to use expert opinion to build a carbon reserve based on the amount, on the probability of risk that this practice could occur. And of course, the practice change would be a tillage reversal for reasons of wet conditions or weeds and so forth. So that's applied as a discount to the coefficients, and one of the reasons why the driver for policy is reducing the science-based coefficient in this case. But it is a good way to assure people that there's an opportunity to address this question of permanence in the whole scheme of things. So there's been quite a lot of uptake in the tillage protocol. I'll leave it for Paul to talk a little bit more about this. And I just want to point out that close to 1 megaton of carbon dioxide equivalent is accumulated in the soil carbon reserve pool against future possible reversals. Lots of challenges, uncertainty, gaps, declining funding and expertise as far as other places where we would like to develop protocols. And then this permanency, I don't think we've quite nailed it yet, but we're still working on it using these different approaches. But there's many opportunities yet, and we're thinking that this is knowledge that's very important for other environmental initiatives in agriculture and beyond, particularly in the area of record keeping, third-party verification, and contracting. So there's a lot of interesting policy decisions right now that are being made around those topics. What's also important, I think, and interesting to mention to these people in this room is the role for professional agrologists in the record keeping, because we know farmers are not great record keepers, but there is opportunity, and this was recommended by one of the auditors who has looked at some of the records that come forward to prove the management practice change, and they indicated that there's a role for a field agent to contribute significantly to this effort. So we've been working on a practice standard that you'll probably hear more about in the near future. Okay, I think
Thanks very much, Sheilah.
Okay, you're welcome.